Hello everyone. Welcome to the presentation of our work for ICIP 2020. My name is Christie Chen and my research interests are computer vision, machine learning, and related fields. Now I'm going to introduce our work collaborated with YouTube. The title is A Comparative Evaluation of Temporal Polling Methods for Blind Video Quality Assessment. You can check out our paper on the link provided in the slides. Here's the content we're going to cover in this talk. So firstly, we're going to briefly introduce the background. Then we summarize typical polling methods in 3 categories. Traditional means emphasizing low quality parts, and means emphasizing memory effects. Next, we talk about the ensemble polling we proposed and show the experiment's results. Finally, we give some observations and provide an empirical recipe for applying temporal polling under different scenarios. So firstly, we're going to start it with a little bit of background. So blind video quality assessment, in short, BVQA, is a low-level vision task to build a model which can blindly predict perceptual quality of a given video clips. So typically, there are 2 ways of building a BVQA model. So firstly, is directly build a video level features and then applying a regression model. So the second approach is to leverage blind image quality models to predict frame level scores, and then aggregated by temporal polling method. As shown in the figure 1, each frame is passed into a BIQA model to get a frame level quality scores, as shown in Q1 to Qn. And then a temporal polling module is applied to derive the final video quality Q sub all. Here we study the temporal polling effects in the second method since it's simple but effective. And there also exists some evidence of temporal perceptron from subjective experiments. Moreover, we aim to identify effective polling methods that can be generally applied on top of any leading IQA models to promote BQA studies. So now we summarize popular temporal polling methods here, so which serve as the benchmark in our studies. So the most popular types of polling is Pythagorean means, which includes arithmetic means, harmonic means, and geometric means. Harmonic and geometric means emphasize lower scores as comparing to the simple means. Another popular means is Minkowski means, as shown in the last equation. Other popular polling methods emphasize the low quality parts are percentile polling and VQ pollings. So percentile polling aggregates the lowest K percentile scores, and VQ polling proposed in this TIP paper, as provided in the link, firstly apply K-means to separate the scores into 2 groups, denoted as G sub L and G sub H, which corresponded to the low quality and the high quality groups respectively. So the final quality score is the weighted sum of 2 quality groups. Another method is the temporal variation polling, which consider the quality variation and then combines the largest K percentile absolute quality differences. So we also introduce more complicated polling methods, which account for memory effects, which basically includes 2 basic indices, the primacy and the recency effects. So the primacy effects describe the tendency of human viewers to recall the earliest portion of a video when providing an overall evaluation. So on the contrary, The recency effect is another well-established behavioral and memory effect, whereby in this context, video quality is very strong influenced by a viewer's most recently perceived visual impressions. So both effects can be characterized as an exponentially weighted sum. So the last method we're going to introduce is hysteresis polling. So this was inspired by the hysteresis effect observed in the human perceptron of time-varying video quality. So let Q sub n be the frame quality scores, and the memory of the past quality L sub n is expressed as the minimum quality scores over the past previous frames. So the current video quality Q sub n is the weighted sum of the ordered frame level qualities over the next frames. So the time varying scores capturing the hysteresis effect should be the weighted sum of n sub n and L sub n at each time. And the final score of the global average of hysteresis transformed predictions is denoted as Q prime. So for our proposed method, we observed that the performance of this polling methods differs and also on a very different data sets. So given that those methods are likely to capture different aspects of perceptual polling, ensemble learning is a direct way to combine those two words, creating a more reliable and generic quality indicator. So we proposed an ensemble-based polling, which combines multiple polled scores to compensate the different method, as shown in this diagram here. The multiple polled scores from Q1 to QM are trained to map the final quality scores, which should have a more robust performance. For the experiment results, like we select 5 popular BIQA models as frame level quality predictors and evaluates all other polling methods on Convid 1K and live VQC. We use the standard 100 random suites of train and test sets, and it reports the median SRCC and PLCC. And here we have our experiment results. So we show the performance comparison of temporal polling methods. And the 3 best results among each column are bold-faced in the picture. This performance result yet revealed different trends on 2 data sets. Convid 1K yields similar results among most of the competing polling approaches, whereas on the live BQC, percentiles, BQ polling, hysteresis, and the ensemble enhancements, e-polling generated the best scores. Towards better understanding of our experiment results, we observed that the live VQC contains the videos that are more camera motions, that contains more camera motions like cheeky ones or a lot of different motions. So hence more temporal variation than those in the Convid 1K. So this is possible that the live VQC contains a larger range of the perceived time varying quality scores, while the temporal quality variations on Convid 1K and here are more closely to the mean quality score level. So in conclusion, our suggested recipe for incorporating temporal polling into the design of BVQA models strongly depends on the video content. So for the videos that contains more motions or temporal quality variations, polling strategies that are more heavily weight low quality events are recommended. So in a situation where the quality variations are low or contains less motions, traditional statistical means predicts might be more adequate. So our proposed ensemble approach can further improve the quality prediction performance on a difficult BVQA problem that is only incompletely understood. Yeah, I think that's all I have for this presentation. And thank you very much for all the attentions. So if you guys have any question regarding the works or regarding this paper, please feel free to drop us an email. So thank you guys.